Alright, we started this lesson last Friday, or I guess last Thursday, but we really didn't get into it very much, so let's go. Alright, so 9.6 secants, tangents, and angle measures. Okay, so we began the lesson talking about a secant line. So a secant is a line that intersects a circle in exactly 2 points. So lines J and K here are secant lines. Basically, it's a chord that continues going through the circle. Since it's a line, not a segment. So when two secants intersect in a circle, the angles formed are related to the arcs they intersect. Alright, so we did briefly discuss this theorem here. The theorem basically says that if two secants or chords intersect in the interior of a circle, then the measure of an angle formed is 1/2 the sum of the measure of the arcs intercepted by angle and its vertical angle. So anytime you have chords intersect on in the interior of a circle, for example here, measure of angle 1 is going to be equal to half the sum of the measure of arc AB plus the measure of arc DC. And the same here with angle 2. The measure of angle 2 is going to be equal to half the sum of arc BC and arc AD. No matter where it intersects, as long as it intersects on the interior of a circle, this will be true. Okay, here's the proof for this. If you want to look through this later, you can, but there it is. The theorem you do need to know here is that an interior angle, if two chords intersect in the interior of a circle, then the measure of the angle is half of the measure of the arcs, half the measure of the sum of the arcs on each side, and same thing here. Okay, so find x for this problem. You can pause the video and try to find it on your own for A, B, and C, and then we'll go over it in a second. So please pause it and try to work them on your own. Alright, I'm going to assume that you work these on your own. So if I ask you to find the measure of angle x for A, remember this is the angle here, so this angle x is going to be equal to half the sum of our arcs TU and arcs RS, so half the sum of 130 plus 84. Okay, so the measure of angle TVU is going to be half of the marker half of arc RS and arc TU. Okay, so half of 84 plus 130 like we just discussed, half of 214. So basically x is going to be equal to 107. Okay, if you worked B on your own, we now have the angle, and I'm asking you to find the measure of one of the arcs. So here the angle is going to be 110 is going to equal to half of the sum of 97 plus x. Okay, so when you work through this, you're going to have to solve for x algebraically. No big deal, right? Just multiply both sides by 2 to get rid of that half, and then subtract this 97 from each side, and you get 123. Okay, and then C down here. Here I gave you the measure of the other arcs, so you needed to find these on your own. So since we know that the measure of angle x is supplementary to the angle measure of angle AEB, and we're given the arcs that correspond with these angles here, I can find the measure of angle AEB and then get the measure of angle x by using the fact that a line is supplementary. Okay, so first off we're going to find the measure of angle AEB, and we know that's going to be half of 75 plus 143, which is going to be equal to 109. So if the measure of angle AEB is 109, what is the measure of angle x? Right, since it's supplementary, we just do 180 minus 109, so x is equal to 71. Good job. Hope you got all of these answers on there. I'll also post this to Haiku as well. Okay, so recall the theorem that states that the measure of an inscribed angle is half the measure of its intercepted arc. If one of the sides of this angle is tangent to the circle, its relationship still holds true. So here's another theorem. If a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is 1/2 the measure of its intercepted arc. Okay, so here, measure of angle 1 here is just half of the measure of arc AB, and the measure of angle 2 is just half of the measure of arcs ACB. Okay, so I want you to find the measures of QPR and DEF. Please pause the video and work these on your own. Okay, there's DEF and here's QPR. Here, I'll minimize it so you can see it. Okay, pause in and work them on your own. Okay, so since this is a tangent, since the tangent line and the secant intersect at a point of tangency, I know that the measure of angle QPR is going to be half of 48. Okay, so, 148, so the answer is 74. Okay, what about the measure of arc DEF? Okay, the measure of this arc here, DEF. If I know that this arc is FD is half, is double of the angle, then what's the measure of arc FD? So let's work it out. Okay. So the measure of arc FD is 128, right? This is just 64 times 128. So now I can find the measure of arc FED, because I know it's 360 minus that arc, because that arc plus arc FD plus arc DEF make up the entire circle. Okay, so the measure of arc DEF is 232. Okay, and then the last thing we're going to discuss is intersections outside of a circle. So the first thing we discussed was intersections inside of a circle, and then we discussed that if the intersections are at a point of tangency, and now what if the two secants intersect outside of the circle? Okay, so if two secants, a secant and a tangent, or two tangents intersect in the interior of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intersected arcs. So when they intersected on the inside of the circle is half of the sum of them. Now we're looking at half the difference when they intersect on the outside of the circle. Pretty easy to remember. So when they intersect on the inside, you're looking at half the sum. When they intersect on the outside, you're looking at half the difference. Okay, so the measure of angle A is going to be equal to half of arc DE minus arc BC. Here the measure of angle A is going to be equal to half arc DC minus arc BC. And here the measure of angle A is going to be equal to half arc BDC minus arc BC. Okay, so the order of these do matter. Okay, so the difference of the measures of the intercepted arc. So you're going to look at half of the one that's furthest away minus the one closest to it. Clearly, the larger minus the smaller, so that way you do not get a negative number inside the parentheses. Okay, so find the measures of angle L and arc CD on your own. Please pause your video and try to work these. Okay, so the measure of angle L, I can use the theorem we just talked about, and it's going to be half of arc HJK minus arc HK. Okay, so I know that arc HJK is going to be 360 minus 102, right? Okay, minus 102. So I know it's half of 258 minus 102, so the answer is 78. Okay, and then this problem here asks you to find them for the measure of the arc instead of the measure of the angle. So here I gave you the measure of angle A, and then I gave you the measure of the interior arc. Now I want you to find arc CD. So all we have to do is set up a simple algebra problem. I know that 56 is going to be equal to half of arc CD minus 95. Okay, so now I just solve for arc CD, and you should have gotten 207 as your answer. Okay, the diagram shows the path of a ray of light as it hits a drop of water. The ray is bent or refracted at points A, B, and C. If the measure of angle AC, if the measure of arc AC is 128 and the measure of arc XBY is 84, what is the measure of angle D? Okay, so the measure of arc AC is 128. The measure of arc XBY is 84. What is the measure of angle D? Okay, so angle D is when the secants intersect outside the circle, so we need to use that formula that we just spoke about. So the measure of angle D is going to equal to half the difference of 128 minus 84. Okay, so I want you to try to work this out on your own. Pause your video and try to work it, and then we'll see if you got the same answer as I did. Okay, so when you work it out, you should have gotten the measure of angle D is half of measure of arc AC minus arc x by. Okay, so it's half of 128 minus 84. You should have gotten 22 as your final answer. Okay, so here's our concept summary. We talked about 3 types of secants today. A secant that intersects at a point of tangency, so the measure of the angle is equal to half of x. We talked about secants that intersect inside the circle, so the measure of angle 1 here is going to be equal to half of the sum of x and y. And then if they intersect on the outside of the circle, it's going to be half of x minus y. Alright, well, your homework tonight is on your syllabus. Please work it out, and we will go over lesson 9.7 tomorrow, special segments in a circle.